Let's roll. Got your calculators fired up right now. Second half of this notes today, some of my favorite type of problems. Probably not going to be yours. I think it might be, though. Today's all about circles now. Circles, because we talked trapezoids, rhombus, kites, triangles, rectangles. We never talked about circles yet. Look back if you need to. Area of a circle. Here we go. Area formula for a circle. What do you got for me? 4. Start us off right. That would be the circumference of a circle. Well, good, Paul, because it's in your packet. There we go. That's why I asked everyone at the beginning. If you forgot, go back. We did it day 1. Okay, here we go. Pi r squared. Everybody good? We would waste a lot of time just saying, hi, everyone. This is a circle. Find the area. We're wasting too much time. Instead, how about I tell you the area? You tell me what the radius was now. All right, so the area is 95. What's the r value? So where's that 95 going to go in? For area, A. So 95 equals pi r squared. I'll turn it over to you now. How do you get r by itself? And just a hint, if some of you guys are going to say square root, remember my conversation with Dylan before. All right, I don't know if that's the best idea to take the square root right away. 27, your next move. Divide by pi, everybody. Divide by pi. We're not ready. Hopefully you're not touching that decimal in the calculator. If you don't rewrite all of it, keep it as 95 over pi. That's fine. If you don't want to rewrite that full decimal, maybe your wrist hurts or something. I don't know. You can leave it as 95 over pi. And then what do you want to do? Final step here. 11. R is not by itself yet. You want to get it by itself? There you go. Now I could take the square root of both sides. There are no round directions, so same thing we've been doing all. Hi. Same thing we've been doing all unit. Let's write out the full calculator display. Just give me a few numbers. I'll write the rest just to make sure you're on the right track. Just give me a few numbers. Four, give me a few numbers here. All right, we're good. And like I've been talking to you all unit, make sure we got our own units on it, centimeters. That's great. That's not what I'm concerned about today. What I want to do is find the area part of the circle. Not the full circle, part of the circle. Everyone see the piece of pizza here I've given you? Everyone see the piece of pizza, part of the circle now. Not the full area, just a portion of it. Hey, that's what I'm going to refer to as a sector. That's your sector right there. That's the piece of pizza or the piece of pie I want you to find the area of. So should I use pi r squared? What's pi r squared for? The entire one, not part of it. All right, so I need a new formula. Ooh, not going to like this because, as you know, I can measure an angle in degrees, and then last unit we found out we can measure it in what? Radians. Yeah, so we're going to have one formula if it's in degrees and one if it's in radians. Guys, listen, please, please. You do not need to memorize both. If you choose to do so, that's your call. But remember from last unit, if you choose to remember the degree formula and it's in radians, what do you have the ability to do? Convert. Okay, so this is your personal preference. I'm going to put both of them up there. If you want to know both, great. If you want to know one, be able to convert. Same thing as last unit. Here it goes. Using degrees. If it's in degrees, The first part of this formula looks a little familiar. Measure of the arc over 360. Remember that? Bless you. This pen is killing me today. Anybody remember that was the beginning of what other formula from last unit? Arc length, arc length. But now we're not going to multiply it by the circumference like we did last unit. We're going to multiply it by the area, pi r squared. It's part of the area. If it's in radians, again, I'm going to give this to you. If you want to use it, fine. If not, it's up to you. Ready? If the angle's in radians, I'm going to do 1/2 r squared theta. And just a reminder what theta is. That's the angle measure, but it's got to be in what? Radians. Okay, that's the angle in radians. You guys make the call, please. You make the call. And make the call early, too. Don't wait till the day before the test and go, I'm going to do this. All right, get in the habit of just doing one thing. Okay, back to you guys now. Back to you. Next example, back to you. Mine's flipped, I know. Mine's on the right up here, sorry. Area of the sector, radius is 8, central angle 60, what's it in, 60? 60. Okay, so I'm just going to use the degree formula. That's what it's given in. So this will be equal to, all right, let me turn it over to, oh boy, big decision number 2. Ready to roll? Who's 2? Ready here? Measure of the arc if the central angle is 60. So I have 60 over 360. And now I multiply that by the area pi. What's my radius here? Oh boy, we're rattled. Radius length? 8, final answer. 8 squared because it's pi r squared. Okay, so we keep going. Notice all the, hey, whoa, notice all the multiple choices are in terms of pi, yeah. So we need to figure out, leave the pi in our answer, which one of those is going to be the correct one in terms of pi. Don't press your pi button. Don't press your pi button. What you should be doing right now, 60 over 360, and then multiplying that by 64. I'll do that with you. 60 over 360. And then multiplying that by 64. Okay, never mind. Oh my God. This thing is gonna, all right, stay with me here because this is not gonna be pretty in the next couple minutes. Oh, I got it first time. Let's see. Okay, one more time. And everyone just saw me hit it once. Okay, we getting 10.666. All right, I wish they taught you this in middle school, but they don't. All my answers are fractions. What do I now press on my calculator to turn that back into a fraction? Anybody? Math. Okay, most of us know. Good. Math, fraction, and it's going to be 32. In case I didn't know the first time, 32 over 3. All right, so we're looking at choice 3. All right. All right, here we go. Nice little game here. I got 4 students, Amy, Beth, Carl, Dex. They had one job. Find the area of sector BOC. Find the area of that sector right there, BOC. Before we look at their work, I want period 3 to do their own work right now. How would we find the area of that sector? Well, first, what's the arc measure? So I would go 108 over 360 times, now notice, did I give you the radius length at all? No, okay, but somebody pick a radius off here that I could plug in. OC, sure. We could have also done OB or OA. So I'll do OC squared because it's pi r squared. And I forgot the pi. Hold on. So pi times OC squared. All right, well, hate to break it to you, but 2 of these kids are embarrassments. They didn't do it right. So we're going to have to go through each one right now and say a yes or a no to them. Ready for Amy? Short for Amy. Here's what she did. 3/10 times pi BC squared. What's the problem with Amy? BC, what's BC? Chord, we needed a radius. Amy, embarrassment. Beth, maybe short for Bethany, I don't know. 108 over 360, looks good so far, times pi times the OC squared. Bethany, you can stay in class. Carl, maybe short for Carlton, Carlson, I don't know. First names are unique nowadays. Who knows? Might be short for any of those too. What did he do? 3 over 10 times pi. Ooh, AB. What's AB? He took half of that. That gives me a radius and squared it. I have one slight issue before I say yes, Carl. 3/10? 3/10? 108 over 360. That's 3/10 reduced. Carl, great job. Stud. Dex, probably short for Dexter. 108 over 360 looks good. The pi looks good. What's the issue? He's squaring the diameter. We need to square the radius. Even though he's taken 1/2 at the end, I don't care. It's not the same as squaring the radius. Okay, he's squaring the diameter. Dex, embarrassment. So it looks like Beth and Carl, you can stay. What would be real nasty is if I started putting names from this class up there, huh? All right, some real life scenarios, but we'll skip over that for now, okay? Who would be who, right? That's probably what you're wondering about. Who would be who? All right, next. Feelings would be hurt. Kids would be crying. It'd be a whole mess. I don't have enough tissues for that garbage. Feelings. All right, a little different now. Now you know the sector area. Now you know it. I need to find the angle now. Okay, I need to find the angle. So I know this sector is 12 pi. What's angle AOC? Hey, does it say how we have to leave our angle? Degrees or radians? No. So we make a class decision right now. Okay, fine. I'm okay with that. That's fine. All right, so let me just write the formula up there for degrees. Even after that, nothing's happening. Good. So we have measure over 360 times pi r squared. All right, let me turn it over to you folks. Hey, 25, where is the 12 pi going to go? That's the area. So 12 pi Measure of the angle or arc. What am I going to plug in for that one? 1. Measure of the angle. Yep. It is a good question. That's why I asked it, Matt, because it's question number 4. That is the question, literally. So I'm going to put a what there? You can leave it M, X, right? That's what I'm trying to solve for. You good, Matt? Everyone else, that's what I'm solving for. What's the angle? Over 360. And then what about the pi r square part? Oh, boy, 15. There you go, 36 pi. If anybody's wondering, Henrik just went superstar on us and just did 6 squared. All right, if that's where you're wondering. 36, how did he get that? Because he can multiply. All right, any algebra superstars in here? Where do I get x by itself? Well, I already knew that. All right, based on where he came from. I know that already. What's on both sides? Well, first of all, what's on both sides? Okay, so eventually what's going to happen? No pi. Good. Yep, no pi. Or they cancel each other out. Yep, no pi. It's not. Look, I'm erasing. Everyone sees this. And nothing is happening. Has its days. So 12 equals x over 360. This is disgusting. Times 36. All right, the pi's are gone. What's your next move? Got to get x by itself. A lot of different moves, actually. Your call. Your call. Suspense 10. Your call. You want to divide both sides by 36? You got it. Divide by 36, everybody. I get 1/3 over on the left. 12 over 36 reduces to 1/3. And over here, I get x over 360. We're moving. We're moving. Next step. What do you want to do? Woo, 19. What do you want to do next? You got it. All right, so that should be, let's see, x equals, and I'll ask somebody for the answer. 1/3 times 360. How many degrees in that angle? 29. When you're ready, you're back there, boss. There's just sheer panic over there right now.
1,080.
Oh. I think you did 3 times 360. You got to do 1/3 times 360, Billy. 1/3 times 360. 1/3 times 360. 120 degrees, yes. Yeah, sure. Here? Yeah. Yep. 3x equals 360. Divide by 3. Yep. We're all good? Okay, now to my favorite part here, which is let's just mash some figures together. Just mash some figures together and find the area of them. It's not even close. You don't have to wait for me on that first one. I don't think you need to wait for me, because I'll figure this out here. I'll talk through it, though. It's 250.